Hi, my name is Naomi and this is my week 4 reading video. The main physics idea is further understanding the gravitational force and electrostatic force formulas that were introduced to us earlier this week in lecture. In the videos, we really work on breaking down the formulas by their variables and components, and even work through applying them to computational models. Something I learned that was already knowledge of mine was Newton's third law, which very plainly dictates that any object interacting with another object both exhibits a force upon and receives a force from the object it interacts with, and the force given and received is of equal magnitude. This was referred to in the videos as the concept of reciprocity. The reason behind this is that in order to act a force upon an object, there is going to be some resistance because the untouched object already had an initial condition. This initial condition could be in motion or stationary, but either way, that object is going to exhibit an equal force back because contact creates that two-way interaction. I was also already familiar with the basic update formulas introduced in the falling object video. Something I learned that I didn't know was the calculus breakdown of velocity update formula and position update formula. The process of how they are altered to involve an integral makes sense, but it was a new way of looking at these formulas that I wasn't as familiar with. Something I learned that sparked my curiosity was the computational model of predicting the motion of falling objects, which was detailed in the very last week 4 video. It definitely had more parts and connections to understand, but it is something that is quite interesting to think about since we are not just trying to predict translational motion in the x direction, and we are now adding motion occurring in the y direction to our data analysis. This applies to my major for sure because in aerospace engineering it is important to be able to predict how a rocket or robot or device being sent to another planet might fall towards the ground. Especially with rockets re-entering Earth's atmosphere, it is extremely valuable to the lives of those returning in the rocket for those running the operation to be able to predict how the rocket will land back on Earth. It is definitely a matter of the y-directional force of gravity and needs to be predicted very accurately. A topic that I found difficult to grasp was connecting gravitational force to the coding. This is a problem that I have consistently and is really only helped by spending more time attempting to further process the steps of the computational model. I think that I also find it very helpful in the journey of understanding to actually have practice with coding the fundamental interaction. Overall, since coding is not a strength of mine, the coding aspect of understanding fundamental interactions is something that I need more work with. A supplemental resource that was really suited for my need of further explanation of this difficult topic was easily found in the textbook. The specific place was under Chapter 3, The Fundamental Interactions, Section 3.6, Gravitational Force and Computational Models. In this section of the textbook, there is an example of code written out, and the chapter also includes details of the gravitational force by itself. It is all in all very useful because part of not understanding the application of the fundamental force is not fully grasping the meaning of its pieces as well. In general, doing the background reading really does reinforce the knowledge behind the fundamental interactions.